So you guys can't see this, I'm sorry. But I will say things about it, okay? So the idea is that there are lots of different kinds of proposals that you might, lots of different kinds of projects you might want to do that are around using technology for learning. Some of them will fit the cyber learning program and some of them won't. If you want to do something about educational impact in the here and now, that's not for the cyber learning program. Cyber learning is about the future. If you want to advance what we know about learning but without technology design, that would be the core program in EHR. That's not what the cyber learning wants you to do that in the context of technology design. Or you want to advance technology design but you're not going to do anything on learning, well, you'll have to find another program for that. Okay? If you want to just do cyber-enabled teaching or cyber-enabled research, but you're not really focusing on impacting learners, you're focusing on teachers or you're focusing on research but not learners, you got to find another program for that. Okay? And if you're studying technology itself rather than uses of technology to help people learn, then that's not the right place to do it. If you just want to implement something that you're going to use in some class, cyber learning is not the right place to do it. But there are all these other programs. Okay, so and like I said earlier, part of our mentoring is going to be to help you figure out what's the right program to go to. Okay, the Circle Center, which supports the cyber learning program, is not simply supporting the cyber learning program. It's supporting cyber learning at NSF, which means the cyber learning program and everything else that anybody else is doing across other programs, that's about technology and education, technology and learning. So let me just go through a few of them. DRK-12, Discovery Research K-12, is for projects where you want to learn some particular things about some particular way of using technology in the here and now. Where here and now means, like, you know, the next 3, 4, 5, 6, 7 years, okay? So learning domain has to be STEM. For DRK-12, the context is K-12. For IUS, which is in the division of undergraduate education, it's about undergraduate education. And for ASL, or ISL, I'm not sure how you pronounce it, it's about informal STEM learning. So, so there's the potential for applicability tomorrow. You know, today, tomorrow, very soon, okay, in the STEM disciplines. STEM plus C is about learning in a STEM discipline intersecting computing education, okay, or computational thinking, and the context there is K-12 with potential applicability for today. So an example of something for STEM C, I didn't write this, so I don't know. STEM C happened after I left, so I don't know. It may also, STEM C may also be undergrad, okay? But it's basically about computer science or computational thinking and its intersection with other sciences, with math, with other STEM subjects, and taking advantage of that intersection specifically. It's got teacher preparation in it. Yes, it does. And DRK-12 and IUS and ASL have teacher facilitated preparation in them as well. Okay. I-Test, which is going on, there's discussion about that going on across the way. The learning aims towards a technology literate STEM workforce. Okay, so it ought to have strong impact on K-12 students and teachers. It's setting up programming that's going to have an impact. It could be programming in school, it could be programming that's done outside of school. That's going to have an impact on the STEM workforce. And uses technology, right? And uses technology. And there's, you know, it's not so much about research. It's more about, it's not basic research. It's how to make things work research. Okay? I'm not going to call that applied research. It's how to make things work research. All of those are in EHR. Okay, they're in the Education Directorate. Cyber Human Systems, CHS, is in size. It's in computing. Okay, and that's research on humans and computers interacting with each other. It's not learning focused. So if there's some new way of having people interact with computers that is what you're interested in, then CHS is the place to get funding for that, right? And then you can move from CHS to adding learning scientists to your team and start taking it into learning after that, okay? ECR, oh, that's now called CORE. CORE, Education and Human Resources Core Research. That's foundational research on STEM learning, foundational research on STEM-related learning, on how you make it happen and how it happens. So how does learning happen in particular kinds of situations? How do you make it happen in those kinds of situations? The processes of learning, not just the outcome, but the processes. If you want to make a product, okay, SBIR, and you're from a small company, okay, or you're working with a small company, then SBIR or STTR are the way to go, because they're both about exploration or development associated with putting a new technology on the market. One of them is if you're the company, and one of them is if you're the university working with the company. That's the difference between SBIR and STTR, I think. There's another program called Big Data, Critical Techniques and Technologies for Advancing Foundations and Applications of Big Data Science and Engineering. Education's one possible application area for big data. So if what you're doing is primarily big data, you should apply there. Now, that being said, if what you're doing is about applying machine learning techniques or some kind of analysis method or something to learning data in order to be able to give the right kind of scaffolding so that people can learn, that's a cyber learning proposal. Okay? And how do you know the difference? You talk to program officers. Okay? You talk to program officers. They can tell you that. There's, I don't know that second to last one. There's Science of Learning Collaborative Networks that came up after I was gone, but it's basic. It says here. You'll be able to see the slides. And then there are programs in size that are about computer science research that may have application to education. I think that a lot of the original intelligent tutoring systems work was funded by SIZE in intelligent systems. So so that's another place to get funding. So it's a big environment. I like to talk about cyber learning, the program, living within an ecosystem of a bunch of other programs. You know, it was my job to make the argument that the cyber learning program needed to stay. And so and that it was really important. And I had to give the people above me the ammunition to be able to do that above them. And I like to talk about, all of this here as being an ecosystem at NSF. There are all these programs that are addressing different issues, and they all need to think about them talking to each other, informing each other. Okay? So cyber learning research in the cyber learning program is going to be informed by things that were learned in CHS and in the SIZE programs and in DRK-12 and AZEL, and cyber learning research in the cyber learning program is going to inform those back in return. So I think that's the way to think about it. Chris wrote this. Maybe I wrote that. I don't know. If it's learning research but no design, apply to ECR, SLCN, or BCS. If it's technology research but no learning research, apply to CHS or another SIZE program. If it's STEM education but not a new genre, DRK-12, AZEL, or IUSE. If it's product development, SBIR, STTR. And if it's learning about technology, not learning through technology, then STEM-C or ITEST. Okay, so that about sums it up.